Okay, so we'll resume from yesterday's slide. So this is the problem statement which I had given during yesterday's lecture. So I will read it for your information. So for typical motor car, the road resistance is given by 23 Newton per 1000 Newton. The air resistance by the expression 0.0827 V square. Transmission efficiency 88% in top speed, that is in top gear. Car is having weight about 19,934 Newton and which is fully loaded. So for this data, we need to find out BKW, brake kilowatt required for top speed of 144 kilometers per hour. Then acceleration in meter per second square at 48 kilometers per hour, assuming the torque at 48 kilometers per hour in top gear, 25% more than at 44 kilometers per hour. So that already we have seen. And number 3, the BKW required to drive car a gradient of 1 in 5 at 48 kilometers per hour. That's speed. When transmission efficiency is 80% in bottom gear. And they have given some units, the resistance being in Newton, V the speed in kilometers per hour, and G that is acceleration due to gravity, and it is having value 9.81 meter per second square. So with respect to the first bit, what is the required formula? That BKW required is equal to RV divided by 3600 into eta T. This eta T is nothing but transmission efficiency. And what is second formula is required? Maximum acceleration. How to define it? So is equal to 1 upon WE, that is effective weight, F minus R. F that is reactive effort and R is total resistance. So unit for this meter per second square. So you can write in your notebook. First of all, we will calculate BKW, that is brake kilowatt required. So you can write formula BKW required. Sachin completed after this?
Yes, sir. BKW already we have calculated.
Calculated, then no issue. R is total resistance and V is in kilometers per hour. Okay. This we have completed?
Yes, sir. Yes, sir.
Okay. So 98.8 kilowatt. So here, what is important in such type of numerical? So after this formula, here units are written. V is in kilometers per hour. 144, that is directly mentioned there. And this one is the transmission efficiency, 88%. How we are writing 0.88, that you know. Accordingly, BKW is equal to 98.8 kilowatt. Then we need to find out acceleration at 48 kilometers per hour. So next line you can write acceleration at 48 kilometers per hour. So for that, just you can see this formula. What is required? This F, this R, and this WE is required. So next line you can write. Already they have given one condition regarding the torque. So you can write T1 is equal to torque at 144 kilometers per hour. Torque at 144 kilometers per hour. And F1 is equal to tractive effort available with this speed. So T1 F1. Okay. Similarly, you can write T2 is equal to torque at 48 kilometers per hour, and F2 is equal to tractive effort. Now from this, so this one is T2 torque at 48 kilometers per hour, and T1 torque at 144 kilometers per hour. What you are going to understand from this? With this speed and with this speed, so you know that relation. So increase in the speed, torque will be less. So whenever speed is less, torque will be more. So accordingly, as per the condition given, T2 is equal to 1.25 T1. This is given. So once again, we can see the condition, whatever they have given here. It is mentioned 25% more than whatever torque available at 144 kilometers per hour. So accordingly, we can have this T2 is equal to 1.25 T1. So next line you can write. Hence, as per the given condition, hence as per the given condition, hence as per the given condition, you can write T2 is equal to T2 is equal to T2 is equal to 1.25 T1. Up to this completed? Sachin, up to this completed?
Yes, sir.
Okay. So this is T2. This one is T1. So we can write in terms of
F1.
this and this. How to write? So F2 into R2 is equal to 1.25 F1 into
Into
R1.
R1.
Okay. So this R1 and this R1 and this R2,
So equal.
there is no change in the radius of wheel. Okay. So accordingly, we can write next line F2 into R. This is also you can write R1, R2 that we have mentioned, but R1 is equal to R2 is equal to R.
Target cancel.
Sachin, बरोबर आहे?
बरोबर बरोबर.
Okay. So next line you can write
Target cancel.
then F2 is equal to as the radius of tire is same. Okay. What is next step, Sachin? So we know value of F1. मिळाली का आपल्याला? This is the tracking effort. So whatever total resistance, based on this total resistance, we got this 98.8 kilowatt. And suppose here this 98.8 is given, and this for time being, if this is unknown, this is R V. हे फक्त समजून घ्यायचं, कन्फ्युजन होण्याची शक्यता आहे. And for this power, what we are going to get? This much tractive effort. Actually, this is the resistance. So this power will be utilized to overcome this resistance. That means we need to have that much tractive effort. So this is speed related to T1. Then this R equal to F. It is also related to the F1 value. समजलं का सचिन?
Yes, sir.
Okay. So based on this, we got this F2 is equal to 1.25 into F1. So here you can write. Here I will add one more step. F2 is equal to 1.25 21.73. Okay. Calculate करून you can check. Is it correct?
Yes, sir.
Okay. So we got value of this F2. Next, we need to find out total resistance. Now, every now and then you should track the formula. This one is R, this is F. So this value we got. Now our aim is to find out R at this 48 kilometers per hour. हे लक्षात ठेवायचा हा फॉर्म्युला. So we have calculated this F. Now what is remaining? This R. So next line you can write total resistance at 48 kilometers per hour. 48 kilometers per hour. Okay. Here I will write RA. Here I will write now check what combination they have given. Point not Sachin सांगा तुम्ही 8
827 V square.
827
V square.
स्लाइड वर आहे ते पण we will see afterwards plus what we are going to write
KW.
huh? त्यांनी दिलंय ना काहीतरी तिथं we will check what formula they have given. You can write in terms of this. So next line 1000 per 23 Newton they have given. Okay. So write down this is equal to, here you can add R is equal to RA plus RR. This 48 इथं घोळ होतो because so 48, that's why we have taken here 48 plus 23. So 23 Newton or 1000 Newton. This is value of road resistance for 19934. What is the value of road resistance, and that is calculated. Okay. Calculate. Sachin, calculate.
2363.89 न्यूटन.
Total.
Okay. Yes, sir. Correct.
649 Newton. Okay. Write down this as the answer. Up to this completed?
Yes, sir.
Okay. So what is value of F? Sanga, Sachin? 27.
2716.67 Newton.
20. No. F. Value of F.
2716.
16.67.
67
and value of R is 649. Practice साठी लिहितोय मला माहित आहे, but still I am writing. Now, how to calculate maximum acceleration? For that, 1 upon W
WZ
F minus R.
R
ही व्हॅल्यू मिळाली, ही व्हॅल्यू मिळाली. What is remaining? This.
WE.
So 1 upon this. मुद्दाम ठेवतोय मी 16.67 minus 649. Now one more term is given in the example. What is that? This acceleration due to gravity, G is given, and this is W. This is W. So this WE, how to write WE? This is effective weight, sorry, effective mass. So already we have seen previously. Then this W is in Newton. Who will tell me formula for this WE? Sachin? Can you have any idea about this? Sachin? Sachin?
No, sir. I forget.
So I will write here W. फक्त तुमच्या माहितीसाठी लिहायचं is equal to mg. Here W weight. This is mass. Instead of that, I will write here effective weight, effective mass. This is G. Then WE is equal to. बरोबर कळालं का आता?
Yes, sir.
So this is in Newton. Units लक्षात ठेवा. Though it is simple Newton, and here it is meter per second square. And finally we are going to get value in kg, as we need to have this weight that is in Newton and G is in meter per second square. Okay. Then maximum acceleration. So please write in your notebook. Therefore, maximum acceleration. Next line, F is equal to 1 upon WE inside the bracket. Up to this completed?
Yes, sir.
Okay. Okay, then you can write this F is equal to now, though it is very simple, just I would like to tell this W is in Newton. This bracket outcome will be in Newton. This N get cancelled, and this G, that is meter per second square. That is the but the acceleration. In this way also you can calculate. Okay. Next line, just by putting the values. Calculate. Okay, up to this completed.
Yes, sir.
Okay. Then what is final value for F? Calculate.
1.01 meter per second. 1.01 meter per second square.
1.017 approximately we can write 1.02 meter per second square. Okay, this is the second bit we got. Okay, then what is third part that is remaining? That is the BKW required when we are going to consider the some gradient, and that is given 1 in 5. So this is second bit we have completed. Next line you can write BKW required to drive the car up a gradient of 1 in 5 at 48 kilometers per hour. 48 kilometers per hour. So we need to find out this power in kilowatt, and additionally they have given there is some gradient. So just we can see this is the total resistance at 48 kilometers per hour. Sachin, am I audible?
Yes, sir.
Now, when this gradient is given 1 in 5, in that case, if this is the resistance Ra plus Rr, here we are going to write Rg, that is the grade resistance, and that we are going to calculate, and that we are going to put value for this R. Here all these things are same. समझ लगा? So this R Ra plus Rr plus Rg.
तर आन्सर 45-56 न्यूटन येते.
थांबा मला बघू दे. एकच मिनिट. Correct. Good. Okay. Then next, draw this diagram. This is schematic, whatever given. Sachin, तुम्ही थांबा थोडं. हा?
हा सर.
Okay. So BKW required to drive the car up a gradient of 1 in 5 at 48 kilometers per hour. Draw this diagram. Okay, completed. 1 minute is more than sufficient. Okay, completed. Amol, school. Omkar, Yogesh, Milind.
Yes, sir, completed.
Okay. Then so for gradient in 5, This is the schematic. So here you can write tan theta from this figure. Tan theta is equal to 1/5. Okay, this is simple. We have seen this for small angle. Tan theta is equal to sin theta. Why these values are required? So this RG is equal to W sin theta. For this sin theta is required. How to find out? Just by taking tan of this angle. Tan theta is equal to opposite divided by adjacent side. Accordingly, we can get 1/5 and is equal to 0.20. So tan theta is equal to 0.20. Not necessary to find out theta. Tan theta is equal to sin theta. That you can write it directly. Okay. Okay. Next line you can write. You can take this value or this. No issue. 196 approximately we can take 0.20. Okay. Then write down. Hence total resistance R is equal to RA plus RR plus RG. Up to this completed, Milind?
Yes.
Okay. Then write down this. Every time everybody should write. That will be beneficial for you to have practice regarding the calculations. This, therefore, R is equal to Sachin. Up to this completed.
Yes, sir.
Okay. Samarth, are you there? Samarth Savan.
Yes, sir.
Okay. Okay. Shreyash, are you there? Yes. Yes, Gadekar.
Yes, sir.
Okay. Mangesh Misal, are you there?
Yes, sir.
Aditya Motevar. Pranay Disle.
Yes, sir.
Prajwal.
Yes, sir.
Okay. Good. Then up to this, if you have completed, then I will proceed. Then we need to calculate this BKW. Okay. So next line you can write BKW required is equal to RP Write down this step and calculate. Somebody should tell me answer. Sachin, what is answer?
75.93 kilowatt.
75.93 kilowatt. So approximately you can write 76 kilowatt. Okay, up to this completed.
Yes, sir.
Okay. So this is whole solution. Screen is visible.
Yes, sir.
Okay. So I will provide canned notes to everybody. Everything is it is in the notes, and you should have solution like this. In which manner I am writing? Like this only you should have representation. कळालं का तुम्हाला? सचिन?
Ha, sir.
So like this everybody try to write solution, and the way I am writing required formulas. Then number 1, number 2, number 3, like this flow should be there. So what is important in the numericals? You should know what to find and which formula is required. So there are 5 to 6 formulas only. Just we will revise. So okay. So this is air resistance. How to calculate kV square? Rolling resistance. How to calculate kW? Rolling means road resistance. Gradient resistance. How to calculate W sine theta? How to calculate the acceleration? 1 upon WE
F minus R.
F minus R. How to calculate drop or pull? F minus R.
R.
How to calculate gradability? That we need to remember. Some formulas we need to remember, other formulas are simple. How to calculate power required for vehicle propulsion? That is RV divided by 3600 transmission efficiency, that is eta T. What is total resistance in case of gradient? That total resistance in case of the gradient, that we can have RA plus RR plus
RG.
total resistance in case of level road, R
A plus RR.
RR. Right? So
Okay.
like this you should remember. What is effective mass? effective mass, it is in kg. So whatever weight of the vehicle divided by acceleration due to gravity, we can get the value of effective mass that we can use to calculate the maximum acceleration. So only 3 to 4 formulas are there, and based on that you can score 10 to 12 marks. Now from this unit, one bit is remaining. Just I will show you the syllabus. Okay. That performance curves, that is remaining, that is in our syllabus. So that if it is there, I will take in tomorrow's lecture, and we'll start the transmission next chapter, that is chapter number 3rd. So before that, I would like to show so for every chapter screen is visible.
Yes, sir.
So like this notes in PDF, so whatever I have prepared with somewhat different diagram, that I am going to provide. Link for that will be added in our study material links. So don't worry about the material, study material. Then we'll discuss regarding EMCQs. One bit is remaining, but time is not sufficient for completing that bit into today's lecture, so that's why I am discussing this. So MCQs will be like this. Sachin, screen is visible.
Yes, sir.
Okay. So like this MCQs will be there. So simple. Dash dash is the resistance offered by air to the movement of vehicle, air resistance. So coefficient of air resistance for best streamline the cars. So you should have those values in your mind so that you can write the correct answer. Coefficient of air resistance for average car. Those values you should remember. Then coefficient of air resistance for truck, lorries, etc. Rolling resistance RR is given by Kw, then this A plus PV into W. What is the answer, Sachin?
KW.
Both of these, both B and C. So rolling
Okay.
resistance depends upon type of road, whether it is pakka sadak, whether it is paved road, whether it is having loose sand. Based on this value of A and B, already we have seen. Similarly, here the force available at contact between the tires dash tires and road is known as tractive effort, right? Now this question itself is confusing one. Here we need to assume that vehicle is having front engine rear wheel drive. In that case we can write here rear wheel tires, and that is known as tractive effort. What I have told you, so front engine front wheel drive, tractive effort is available at the front wheel tires. Front engine rear wheel drive, tractive effort is available on the rear wheels. Now here rear wheel tire, front wheel tire, front and rear wheel tire. मग आपण जर assumption केले बाबा फ्रंट इंजिन rear wheel drive आहे, त्या केस मध्ये हे उत्तर बरोबर आहे. Now if we are assuming front engine front wheel drive, then front wheel tire, and front and rear wheel tire, it is related to the all wheel drive. So they would have mentioned here some specific things, then we can write. But such type of question, now these three answers are correct. Sachin, लक्षात आलं का मी काय म्हणतो? Hello?
Yes, sir. Yes.
Because they have not mentioned whether it is front engine, front wheel drive, front engine, rear wheel drive, or all wheel drive. कुठलंही यातलं उत्तर बरोबर येत असं वेग स्टेटमेंट नाही करत मी. असं जे कन्फ्युजन ज्या क्वेश्चन मध्ये असतं, इन दॅट केस दिस इज द सिनारिओ. ओके. Then air resistance depends upon size and shape of the vehicle. Size, shape, speed of the vehicle. Only speed of the vehicle. Only wind velocity. So you should think, you should search about such questions, not for your final examination, but for understanding it in a better way. Okay. So just I am stopping here. So tomorrow's lecture will within 15 to 20 minutes we'll complete that last bit, performance curve, and then we'll start third chapter. Okay. Please wait for a minute. I will take screenshot.